Hello, this is going to be part 3 of my video series on angular compression and the Rayleigh Criterion, which was brought about by watching a video by Gary Waibenga. And I'm going to put a card right about here for the playlist that I'm going to create for this series. If you haven't watched part 1 or part 2, I would recommend that you watch those, and this one is also going to be included in the playlist. If you don't want to do that, I'll just recap what those two videos were about. In the first part, I tested the camera's ability to resolve detail and at what point the Rayleigh Criterion might come into play. And in the second one, I looked at the camera's sensor resolution and how that might affect the quality or the resolution of the image that is captured. At this point, I've analyzed the camera's ability to optically focus the light onto the sensor and have the sensor be able to register the detail accordingly. And now I want to continue this by looking at what the camera does internally and to turn the output of the sensor into a video file. Back in 2019, long before there was a thing called COVID, I took my P1000 and I went to the Nepean Sailing Club and I looked up north towards where the water comes from, and I get about a good 6 or 7 kilometers distance before the river kind of curves off in this direction and I can't see any more of the river. I filmed this at the start. I was looking to capture some video footage of boats on water, and I was thinking I was going to use those at some point to try to prove Earth curve. I don't know about you, but this certainly looks like Earth curve to me because I cannot see the bottom of this sailboat, nor can you see the hull of these sailboats that are docked on the shore. They've lowered the sails, but this is pretty close to the bit rate of the image that was taken from the camera. I did scale it down to 1080p and I let this thing use however much bit rate it wanted, so it would not impose a cap on the bit rate so that it would give as clear of an image as it could. And in this part, I would like to show a couple of things. As I'm panning the camera left and right, you can see that there are some still frames where the camera was able to capture a fairly clean image like this one here. And you can see this sailboat was anchored in the water, and you could see the anchor line or whatever that's called right here. This is a good clean still, but if I move it a little bit more, you can see that there are moments like this here. In this frame, I was moving the camera rapidly in the middle of it taking a frame, and it's blurry horizontally. And in this case, you can barely see the tether line where they anchored the boat. You can see the mast is very blurry. There's not much definition where the window is. And then of course, when I stop moving the camera, things seem to be a lot more clear. That was the original source of the video, or as clear as it could be without lowering the bitrate. And one of the things that I've seen a number of flat earthers do is they will look at a video online of people zooming in or zooming out, and they'll see that the boat disappears or that certain parts of the boat will no longer be in view. And if you watch part 1, I put a link to Gary Waibenga's original video in the description. He stated in that video that there is a buoy that is painted one color. I think the buoy is yellow, and the bottom of the boat is painted orange. I'm going by memory. As he shows in the screen capture, replay, and repost, at some point, yes, the bottom of the boat and the bottom of the buoy appear to disappear, and he says that that is due to angular compression. And I did get into the technicalities of video compression in a previous job that I had, and so I've got some small idea of how compression works in general. And there's a couple of things to consider when you're dealing with video codecs. There are certain things that we are able to see very readily, and there are certain things that we cannot make out very easily. And one of the jobs of a video codec is to choose whichever method is needed to save as many bits as possible while maintaining a visual quality that we cannot tell the difference between the original and the compressed. There are a number of tricks involved. One of the things that the video codec will do is it will look at the detail in successive frames, and it will detect motion in the image. So let's say you're panning the camera left and right like what I was doing. The codec will recognize that a lot of the detail remains relatively static as the camera is being panned left and right. And so what it will do is it will tell the video decoder to take the previous image, shift the entire image over to the left by so many video blocks, and then it only has to repaint this small set of blocks on the right hand side, and that way there it allows the codec to save a significant number of bits. But one of the very big things that a codec deals with is our ability to discern contrast level, but we have a fairly weak ability to differentiate between adjacent colors, and so the codecs will take advantage of this in a lot of cases. Here's the original image. It will break the image up into the brightness level, so it'll basically make a black and white image, and then it will break the color up into a CB and CR color scheme. And one of the benefits of doing that is that it will group 4 pixels, so 2 pixels left and right and 2 pixels up and down, into a single color pixel for the CR and a separate one for the CB, whereas it keeps the 4 luminance bits, the Y channel, and that's going to be it's going to be a I think is it a 1644, something like that. I kind of forget what they are. There are different gradations of the YCRCB standard, and so when the codec goes to compress each of these channels, this one is much larger than these two, and you end up having the codec save some of the bits. So what I'm going to do is, if time permits, I'm going to play some of these other ones at the end of this video. Hopefully YouTube is not going to degrade the quality of those parts of the video even more, and so that you'll be able to see the full loss of detail without YouTube adding more loss on top of it. But I've been lowering the bit rate. This one is 12.5 megabits per second, and so far this one still seems to be keeping up with the quality, relatively speaking. Even when I'm moving back and forth, you can kind of see that the detail is still more or less there. I've lowered it even more, and at some point you can still see the tether line fairly clearly if I keep lowering it even more. So now this is at 3125 kbps, and here you can start to see that the codec is losing some of the detail of the tether line, and there should be a white pixel here, but it's kind of been blended into the blue. And again, that is one of the trade-offs that the codec has done in order to fit as much of the detail as it could in the bandwidth that I've allotted for the video. Here I made the image even smaller, so a smaller video with less bandwidth, the same 3.125 megabits per second. Here you can see as I'm panning around, it's not selectively filtering out some of the tether line. It does seem to represent the entire tether line. Even here I can still see that there is no spot where it's filtering it out and just bleeding the water where the line should be. This is going to be a bit of a preview for the next video, but I'm going to include it in this one because the point of this was I also wanted to use something that was fully computer rendered. Here I've lowered the bitrate to 500 kilobits per second, and you can see that even though the intensity and the colors themselves still seem to be represented fairly well, it's lowered the number of bits associated to the CR and CB channels, and as a result you can see the bands of the colors a lot more clearly than you did in the first one. And as I lower it even more, you can see that it gets even worse and even worse. So when a flat earther makes an argument that you can use a camera to zoom in and to get past the quote-unquote angular compression and bring back into full view a ship, one of the main problems with that argument is not the fact that it's the light going through the atmosphere, hitting the camera, going through the lens, not being cut off by the Rayleigh criterion, not being affected by the resolution of the camera's sensor, but that a lot of the argument being made is really a false, even misleading argument by the virtue that it is a loss of image quality through the compression algorithms that are used, especially when a video is being made of another video. The person making the original video had the camera compress a video. They may or may not have recompressed it by using a video editing tool. They've uploaded it to YouTube, which almost certainly have recompressed it. The person such as Gary Wybenga, who did a video capture, has had their phone or their computer do a screen capture and a video recompression. They may or may not have run it through their own video editing software, re-uploaded it to YouTube, who will have done a recompression on that. So depending on the circumstances, there may be as few as 4 video compression cycles done on the image, possibly 6 or more. And each step along the way is like making a photocopy of a photocopy of a photocopy, and anybody who's done that will realize that you do not have to make that many number of copies of the copies before you get an image that is essentially unreadable due to the subtleties of the changes in the image quality in each successive copy. At this point, I'm going to put a copy of the section of the video that I filmed at the Nepean Sailing Club as it appeared straight off of the camera. And depending on how long this video is going to be, I'll include a few more videos with lowered resolution along the way. That's going to be it for now. If you like this video, I would appreciate the thumbs up, the subscribe, all of that other good stuff. And I'm going to see you again in another video soon enough. So bye for now.